converting each character of a string literal to their corresponding ASCII value. January 7, 2023. This is a Java program that I managed to create yesterday, after stumbling upon a certain method of the string class, namely the codePointAt method. The objective of this program is to display the ASCII value of each character of a string literal read by the scanner object, which detects user input in the console. I found out that a certain number of string methods, such as the replace, charAt, indexOf, trim, toUpperCase, toLowerCase methods, are taught in certain Java programming tutorials, but the codePointAt method is generally not taught. Despite this, it should be noted that this method is the core of this program. In the following paragraphs, I am going to expound the syntactic details of the code snippet of this program. In the beginning of the code snippet of this program, I imported only one class in the java.util package, namely the scanner class, which had been introduced in Thoughts on Java 8 Episode 1. After typing public class, I typed the name of the public class ASCIITextToCodeConverter, followed by an opening curly bracket. After the opening curly bracket, I defined method main. In the beginning of the body of method main, I invoked the println method in the system class for always printing a welcome message in the console for using the ASCII text-to-code each time the program is compiled and run. Next, I typed a while true statement to declare an infinite loop. In the body of this infinite loop, I typed the rest of the code of this program. In the beginning of the body of the infinite loop, I invoked the println method in the system class to print a prompt message to ask for user input in the console. Since this statement is within the infinite loop, it is printed in the console each time the program is compiled and run. After the scanner object was instantiated with the standard input stream, system.in, the annotation at suppress warnings resource, which was generated by a quick fix in the tooltip message resource leak, scanner is never closed that pops up when the mouse cursor is hovered over the yellow underline defined name of the scanner object, was placed before the scanner object. After instantiating the scanner object, I instantiated a string object named str, and assigned the next method in the scanner object to str. Despite the built-in methods such as nextInt and nextDouble, it turns out there is no such method as nextString method in the scanner class for this purpose. The next method is used for finding and returning the next complete token from the scanner object. This is perhaps due to the fact that string is a reference type in Java. After invoking the next method in the scanner class and assigning it to str, I declared a for loop with an initialization of assigning 0 to the index I, a condition of I being less than the length of str, which is an int value returned by invoking the length method in the string class, and an iteration of the post increment operator ++. Since the for loop is in the body of the infinite loop, it might be considered as a nested loop. After the initialization, condition and the iteration, I typed an opening curly bracket, after which I declared a char array of the length of str. The syntax of declaring this char array is arranged by the following in sequence: the keyword char, a pair of square brackets, the name of the char array, an assignment operator equals, the new keyword, another char keyword, an opening square bracket, the name of the string object str, a dot, the length method, a closing square bracket, and then a semicolon. Next, I invoked the charAt method in the string class for str, passed I to the index of this method, and assigned each value returned by this method to each value of the char array. By invoking the println method in the system class, an informative message detailing each character of the string object is printed each time the program is compiled and run. Since I invoked this method within the infinite loop, it should be noted that since a char value is bracketed by single quotes in Java, I placed an opening single quote after the word of on the left side of the string literal in the println statement, and a closing single quote before the word is on the right side. Next, I declared an int array of the length of str. The syntax of declaring this int array is similar to that of declaring the char array mentioned above, therefore I am not going to expound on it one more time. Next, by invoking the codePointAt method and passing I to the index of this method, it is possible to obtain the corresponding ASCII of each character of the string literal read by the scanner object as user input in the console. In the next paragraph, I am going to elaborate upon the two crucial methods used in the string class, namely the charAt method, the codePointAt method. Simply put, the charAt method returns the char value at the specified index and an index ranges from 0 to length -1, whereas the codePointAt method returns the character, Unicode code units, at the specified index and an index ranges from 0 to length 1. It turns out that the first method is used for obtaining the char value at a specified index in the string object, whereas the second method is essential for converting any char or character of a string literal to their corresponding ASCII value. It is also possible to convert any char or character of a string literal to their corresponding Unicode value, but this conversion does not appear to work in the console, as certain Unicode characters such as hiragana, katakana and kanji, which are processed by the scanner object, are not properly printed in the console by invoking the println method in the system class. It should be noted that since the index starts from 0 in both methods, the first character of the string object is at index 0, whereas the second character is at index 1, the third character is at index 2, etc. Additionally, the main difference between these two methods is that the charAt method always returns a char value, whereas the codePointAt method always returns an int value. In response to the tooltip message resource leak, scanner is never closed mentioned above. While attempting to close the scanner object in the infinite loop by invoking the close method in the scanner class, no syntactic error occurs, but after the program is compiled and run, either a legal state exception or no such element exception might be thrown, depending on the place of the close method in the code snippet. If the close method is placed between the scanner instantiation and the invocation of the next method in the scanner class, a legal state exception occurs immediately upon compiling and running this program. If the close method is placed anywhere after the invocation of the next method in the scanner class, no such element exception occurs after first-time user input. In order to not cause either of these exceptions, I generated the annotation of suppress warnings resource instead of invoking the close method in the scanner class. It turns out that illegal state exception still occurs under the circumstances mentioned above, regardless of whether the scanner object is instantiated within an infinite loop, but no such element exception does not occur under the circumstances mentioned above, if the scanner object is not instantiated within an infinite loop. The output of this Java program is that, immediately upon compiling and running this program, a welcome message for using the ASCII text-to-code converter is printed in the console. Then a prompt message asking for user input is printed in the console. Typing any letter on the keyboard results in the green display of the string upon hitting the enter key. The ASCII code of is printed in the console for as many times as the total number of characters of this string, with representing each character of the string. Then the same prompt message asking for user input is printed in the console again, and the process repeats on and on, until the program is manually terminated. In my opinion, this is a neat offline tool for converting text to ASCII without searching it up online. The code snippet of this program is syntactically simple, but it involves a few programming concepts that I have never touched upon before. Therefore, it is a good practice for uninitiated programmers with a little programming experience. Yesterday, I also created another Java program that is more syntactically complex, has a graphical user interface with swing components, and serves the purpose of converting any character to its corresponding Unicode decimal, and converting any Unicode decimal to its corresponding character. I am going to introduce the syntactic details of the code snippet of the more syntactically complex program next time. For now, the key points of this program are summarized below. Key points: I is the default letter assigned to the index in a for loop, refers to the user-defined name of the string object, refers to the user-defined name of the char array, refers to the user-defined name of the int array for, and I equals 0 I. Length I plus char, equals new char. Length, I, equals. Char at I int, equals new int. Length, I, equals. codePointAt I. Import java.util.scanner. Public class ASCIITextToCodeConverter. Public static void main string, args, system.out.println. Welcome to the American Standard Code for Information Exchange plus, \n text to code converter. While, true, system.out.println. Enter any text to convert to ASCII code, at suppress warnings resource. Scanner equals new scanner system.in, string str equals scanner.next. 4, and I equals 0 istr.length I plus, char. Input char equals new char str.length. Input char I, equals str.char at I. System.out.println. The ASCII code of plus input char I, plus is, int, ASCII_code equals new int str.length. ASCII_code I, equals str.codePointAt I, system.out.println ASCII_code I.